Today we're taking a look at section 2.3 on set operations and Cartesian products. We'll be looking at some even-numbered exercises that are found on page 75 in the textbook. And we're going to begin with exercise number 2. In number 2, we're looking at a matching problem. The union of A and B, and we need to find its proper designation in column 2. We're told A and B are both sets. So the union of A and B, the set of elements that are in A that are not in B, set of elements common to both A and B, set of elements in the universe that are not in A, set of elements in B that are not in A, the set of ordered pairs such that the first element is from A and each second element is from B, with every element of A paired with every element of B. Okay, so far not the right answer. Let's hope F is it, the set of elements that are in A or B or in both A and B. So that one's the correct description for the union. Okay, in our next group, we are doing we have been given some sets and we want to actually find different sets. Let's look at number 10. We want to find Y intersect Z. And if we look at Y, for the intersection we need the elements common to both sets. We have A, B, C, and Y. And in Z we have B, C, D, E, F. The ones that are common are B and C. And notice the use of the braces to indicate we have a set. Let's go to number 20. We have X complement union Y complement union Z. Okay, so X complement, let's list those. If we look at set X, it contains A, C, E, and G. That means X complement would contain B, D, and F. Y complement will, let's see, Y contains A, B, and C, so Y complement would contain D, E, F, and G. So if I get the union of those two, which is what's in parentheses, remember we want to do parentheses first, we get B, D, E, F, and G. We want to list everything that appears in either set or in both sets. Now we want to union that with Z, and Z contains B, C, D, E, and F. So that means our final answer here, we're going to have B, C, D, E, F, and G from up here. So B, C, D, E, F, and G. Okay, let's do one that involves a difference. Let's look at 24. In 24 we have Y minus X. Okay, and here's our set Y. Y contains A, B, and C. Set X contains A, C, E, and G. So what we want to do is remove any of the elements from Y. See, we're subtracting X that we find in X. We find an A and we find a C, so that leaves only B. So we start with set Y and we just remove the elements we find in X. Okay, let's look at number 30, and then I think we can call it quits for this group. X-intercept Y complement intersect Y intersected with X complement. Okay, we have Y and X. Okay, so first of all I'm doing X intersected with Y complement. What do they have in common? Okay, x intersect y complement. Let's see, it looks like E and G. Okay, now y intersect x complement. Okay, this time, let me get the blue. We want y intersect it with x complement. So let's look and see, what do they have in common? They have B, and that's it. And now if we intersect both of these, what do those have in common? Well, comparing these two right here, they have nothing in common, so our answer is the empty set. Okay, turning the page in the book. I'm not having you describe a lot of these in words. Let's just take a look at number 40. It says, let T be the set of listed effects of tobacco, and let A be the set of listed effects of alcohol. Find each set. Okay, so it would be T intersect A. So tobacco is represented by T. We have emphysema, heart damage, and cancer. Alcohol, which is represented by A, is liver damage, brain damage, and heart damage. So what symptoms or results do we have in common? We have heart damage, which is represented by the letter H. So the intersection of T and A would just simply consist of H. Okay. Now in 56, we'll move to the next page. We're to find x intersect y and y intersect x. So x intersect y and y intersect x. Okay, if we look at x and y, what do they have in common? They have 1 and 3. If we look at y and x, they have 1 and 3 in common. So we would say that x intersect y equals y intersect x. That would be one conclusion that we could draw. Or you could say intersection is commutative. Remember, we talk about commutative property when we're adding and multiplying. 2 plus 3 is the same as 3 plus 2. It is what we call commutative. Addition is commutative. So that's what they're asking for in that group. Okay, our next one that I want to take a look at is number 66. 66 says the ordered pair 213 equals the ordered pair 13,2. Okay, the important thing in an ordered pair is the order, and we notice the first elements are different, the second elements are different, so that one is false. In number let's see, we'll go on to 72, and we'll do A is 3, 6, 9, 12, and B is 6 and 8, and we're to find A cross B and B cross A. Okay, what I like to do is take each element of A and match it with the elements in B, so we'll have a 3 and a 6, and a 3 and an 8, then a 6 and a 6, a 6 and an 8, then a 9, I'm moving on to this one, 9 and a 6, comma should be outside, and a 9 and an 8, and then finally moving on to the 12, we'll have a 12 and a 6, and a 12 and an 8. If we go the other way, B cross A, we're going to start with the elements in B and match them with every element in A. So I'm going to start with a 6, match it with a 3, a 6, a 9, and a 12. Then I'm going to take the 8 and do the same thing, match it with 3, a 6, a 9, and a 12. Sorry about my messy writing there. Okay, number 78, we're to find the number of elements in A cross B. Okay, so number in A is 13, number in B is 5, number in A cross B is the number in A times the number in B, which here would be 13 times 5, or 65. Number in B cross A, we want to do the same thing. Number in B, number in A equals 5 times 13, or 65.